So now I would like to give a brief introduction of today's speaker. Dr. Jagadish obtained his PhD in mechanical engineering with specialization in manufacturing engineering from National Institute of Technology, Silchar, and post-graduation in product design and development from National Institute of Technology, Warangal. He has over 3 years of industrial experience in the field of design and analysis and 8+ years of teaching and research experience. Presently, he is working as an assistant professor in the Mechanical Engineering Department of National Institute of Technology, Raipur. Prior to NIT Raipur, he worked as assistant professor in the Mechanical Engineering Department of National Institute of Technology, Silchar, Assam, of almost 5+ years. His area of interest are green manufacturing, advanced manufacturing processes, additive manufacturing, product design and development, surface texturing, CAD/CAM, composite material, decision-making tools, MCDM methods, renewable energy, thermal systems and its optimization, etc. He has supervised 13 MTech, 3 ongoing students so far, and presently guiding 5 PhD scholars. He received an institutional award, gold medal by Institution of Engineers India, and Best Innovative Award by Springer for his outstanding research contribution, and published more than 40+ research papers that includes SCI journals, conference papers, book and book chapters. He has given many keynote speeches, expert talks, and repeated conferences, workshop, webinar, etc. He is a regular reviewer of various manufacturing and optimization related ACI index, journal, conferences, books and book chapters. He is the life member of professional bodies like Associate Member of Institute of Engineers, India, Member of American Society of Mechanical Engineers, ASME. Thank you, sir, for joining with us. We are very happy to welcome you. Now I would like to hand over this session to you, sir. Over to you, sir.
Thank you so much, Dr. R.H. Gajgat, sir, for your kind introduction, as well as, am I audible?
Yes, sir.
Yeah, okay. My voice is clear, right?
Sir.
Okay. Thank you for your kind introduction about me, and as well as giving an opportunity on this big platform of ATAL workshop, which is on 3D printing and design. And also I welcome all the participants who have joined this session, even morning as well. So through this my slides, so today I'll discuss about, as already Dr. Gajgat has already mentioned, that today I will going to be discuss on the topic of 3D printing materials. I mean, materials for 3D printing, or maybe additive manufacturing system. So, and this topic is very, very important as today's scenario. If you see, Industry 4.0, always all the industry is moving towards the Industry 4.0. So this topic is very relevant. And I once again congratulate Dr. Gajgat sir and his team members, as well as Institute of Christian College of Engineering, Bhilai, for once again inviting me for this today talk. So now I will start my presentation through sharing my slide. I hope my slide is visible to all of you.
Yes, sir.
Okay. Once again, welcoming to all the participants. So today we will discuss, rather I would just share knowledge on, or maybe expertise in the areas of what are the different types of 3D printing materials which basically used in additive manufacturing systems. So this is just an outline of my presentations. In the approximately in the 1 or 2 hours, I will be discussing on these topics. So I'll start with basic of additive manufacturing, what basically it is, and how this concept of additive manufacturing and 3D printing has arrived in the industrialization, and as well as the what is the working principle basically of this particular AM technology. It's a advanced manufacturing system part, and the applications of few glimpses of the applications of the AM or maybe 3D printings. I'll just share with you, and I'll discuss about just an overview of SLA, FDM, and SLS process. These are most commonly used additive manufacturing systems in most of the industries and as well as in academic research. Moving forward, I'll discuss about different materials which are used in additive manufacturing systems, maybe specifically in the FDM systems or SLA systems or SLA systems, and many more. And then lastly, I'll share you some of the scopes and challenges which still are there in the area of materials as well as in the additive manufacturing systems, and one can explore that as well. So moving forward, the definitions. I hope this definition might have already been shared by other experts in the morning session maybe. So let me just summary, or I meant to say that just to give a brief about what is additive manufacturing is. So basically additive manufacturing, we all know that it is a kind of manufacturing method or the technique or the process wherein we produce the parts or the develop the products directly from the CAD models. That is what we basically always say the definitions. Yes. So here what we are basically doing is we are developing the model so that refers to the what basically is additive. So how this additive is came into picture, because here the main basically this additive manufacturing where we are adding the materials rather than subtractive. In most of the manufacturing systems, when we talk about maybe whether it is a conventional systems or even non-conventional machining processes, we always use to get a products, we do some processes which removes the materials. So to get the finished products, in the case of maybe if I talk about lathe machine, drilling process, welding, or even moving forward, the advanced manufacturing systems like what is called as EDM, laser beam machining, and so on. If you talk about all these non-conventional machining systems where we remove the materials to get the final product, there is another technique what we are now I'm telling you, that is additive manufacturing, where we are not removing the any materials. Instead, we are adding the materials to get a required products. So okay, that required products can be used as a directly to the functional applications, or sometime we basically go for some prototype models for preliminary analysis of a product. So as such, this additive manufacturing is also refers to the class of manufacturing methods which quickly produce a physical prototypes from the 3D CAD data. So here the input is nothing but here your CAD data, that is computer aided design data is required. Directly using the computer aided design data, you are converting into a physical product. So that is the concept is called as additive manufacturing. As you can see in this figure, this is figure number 1, where a model is been developed in a particular CAD model. So this CAD model, is developed by using various CAD softwares, and maybe various 3D CAD softwares are available, like maybe what is called Unigraphics, CATIA, ANSYS, sorry, not ANSYS, and other SolidWorks and ideas, so on. So where we whatever the requirement of the design for the customers you are designing, and then that designing is sent to the a particular process is called as additive manufacturing process, wherein we are add the each layers, different layers by layers to get the products. So these layers are basically is a materials or maybe the cross sections of the component. So that is actually during the conversion or while depositing each of the layer, before there are pre-processing activity will be carried out to send the input data to the machines. Then machines will carry out the responses, the input data, and finally you will get the products which is required product. So you can see this figure also where the cup model has been developed by using some 3D software, and this cup models has been converted into the physical models in the form of different layers. As you can see in this, if you observe this particular figure, you can able to see how the layers have been deposited one upon each other. So basically what happens here is you are adding the different layers of components of the materials to get the final products. So at every layers, you are depositing a certain amount of thickness to get the final products. So this here there are various factors will come into picture. The quality of the end product or the additive manufacturing products will depends on various factors. There are most commonly factors are maybe layer thickness we basically talk about. Okay, so this layer thickness is very important parameters because this decides the quality of the product. Okay, so the quality of the why, because the this smaller the layer thickness, that means when I'm talking about a very lesser size or the height of the thickness, greater the quality of the products you will get. But when we talk about a very smaller thickness, there is another diverse effect is the time consumption or time of the product manufacturing So that is also one factor. So because if you are reducing the lesser layer, a layer thickness, so it takes more time to develop the products. So, but we need the good quality as well as the time very to be complete, or time to be taken for completion of the job is also lesser. There comes the optimization and all to optimize the parameters to get the optimal projects. So what my intention to saying is that what basically additive is nothing but, as the name indicates, here we are adding the materials to get the products of the final products. So sometime we referred this particular technology is called as a layer manufacturing technology as such, because it is being added layer by layer to get the products. Sometimes we call as a rapid prototyping. Rapid means a very fast way of developing the prototypes models for doing the preliminary analysis for the products. Or sometimes we call as a rapid manufacturing, where we are talking about means faster way of manufacturing. And in overall way, we say sometime is called as 3D printing process or three-dimensional product model process. So most commonly we use nowadays the relevant word for the additive manufacturing is the 3D printing or 3D technology. So when we compare this particular new technology called additive manufacturing in comparison with the conventional systems, what we have so far, the conventional systems may be lathe machines, milling, drilling process, or welding process or sawing process, where we can see this where we are getting the products, final products. We are getting the final products by a removal of different materials on the objects. Let's say if it is an example of this particular example figure, as you are seeing in the PPT. So this is a steel component, which is maybe somewhere else it is used for carrying the load applications, right? So you want to manufacture this particular object in a conventional method, or maybe any non-conventional manufacturing systems, as also you require to be remove some materials, isn't it? So that means you need to remove the materials to get a shape kind of things, right? Like this shape. And also, and you are going to put a hole, that means drilling operations you need to do. So whatever the kind of operations you are performing on this particular a simple component, where you are removing the materials, and finally you are obtaining the final shape. And this, if you are using in the real practices, it carries the similar load which you are expecting. That is what the conventional system is concerned. But if you manufacture the same component by additive manufacturing system, there what we are adding, we are just adding the layer by layers. That means the once your CAD model is ready, That means that is enter or sent to the machines where you are adding the different materials one upon each other. As you can see, this is the first step where the material is added. And the second step is also where the material is getting added by line or layer by layer. And the third is also, it is a step where the entire product is completed. The product is completed. So what I'm trying to say here is the difference between the conventional and additive manufacturing systems. So in the conventional manufacturing systems, to get us the same product, we are we are applying the processes that removes the materials to get the finished product. Whereas in the case of additive manufacturing systems, we are adding the materials to get the finished product. And also the less here the wastages of the material what we are removing, that is increases depending upon the complexity of the product. Whereas in the case of additive manufacturing, there is no wastage of the removal materials. So we are just adding the as required dimensions and it's slashing, then adding the different layers to get the products. So and the similar, if you use the same components in the real practices, it can work well with as compared to the conventional manufacturing methods. So that means the simple difference between the conventional and additive manufacturing is where the conventional manufacturing systems, where removal of the materials will subtraction process, where you are subtracting the materials to get the products. Here you are adding the materials. That means you are, that's why it is called additive manufacturing. The second one is the wastage materials, which we do well after doing the process. We are removing the materials. That material is removing, that is a waste of, again, it's a burden of the cost of the materials. So that is a scrap, there is a waste. But in the case of that, we can there is no scrap in the additive manufacturing systems. Somehow sometime, if there is a hollow parts are there, sometimes support materials is needed to develop the products. That support materials is an extra materials which needed for doing the particular object of halo or some complexity of the product. So then comes to the where this concept of AM has arrived, right? How this concept of additive manufacturing came into pictures. As we know already that we used to do the printing process in everyday, in daily life, we do the printing. So that is a 2D form. No, normal printer will print the, what is called as a 2D form. That means in X direction and Y directions. The concept has came from the printer, that a printer can able to print in X and Y direction. Okay. But only additive manufacturing systems what do it prints in the Z direction. So the printer, it cannot do, right? In the printer, it cannot do the Z direction. It can only print the X and Y directions only. That means the sketch which is on the 2D sections in X direction, Y directions can be printed. So with that, the concept of printer, it has been arrived. That means when a particular printer is able to print the material, basically 3D printing means, as the name indicates, it is printing the materials or printing the object or printing the sketch. Okay, as the printer is also do same thing. Whatever you send the sketch, it prints on the 2D papers, isn't it? So as the concept from the printer, it is arrived and thought to give the another direction of printing, that is a Z direction, that is a height direction of the part. So with this concept of height, addition of the height direction printing, the additive manufacturing came into picture. So that nothing but development of 2D sketches in a computer aided design normally we do. And then the next concept is came for layer joining, because in the high directions you need to join the layers of the product. That means the height of the products, or maybe height of the products. Okay, right? So that means the layer joining. And there is another technique, another method is the basic concept of developing the AM is the extrusion in a CAD. So that means extrusion method is another where you are adding the padding of the materials, what we call as adding the materials in the Z directions. Okay, so when you have the X and Y directions, we are adding the Z directions. So that results in a three-dimensional products, and that ultimately, so by adding layer by layer, so finally you will arrive at a particular component called as 3D component. 3D components. And this figure, as you see here, so this is a building structure is been developed or printed by 3D printer, right? So that means the conventional printer to the 3D direction, 3D products is obtained from the concept of the printer. So as we know that the concept behind of additive manufacturing systems, how this additive manufacturing systems has arrived in the market, or maybe in the technology side, for getting developing the 3D components. So what are the such method steps we basically use in the case of additive manufacturing systems? One is called 2D models, extrusion models. That means where you are adding the materials in the another direction, because 2D is having a XY direction here. X and Y direction is there. Extrusion process or extrusion, the command we use for adding the materials and the other side of the perpendicular directions of the axis. That means this is a X direction, this is a Y direction, and the another is a Z direction where you are adding the materials. That means here the extrusion process, and then extrusion, that you will get the 3D model, and that 3D model will be sent to the what is called as the machines, where it prints the exact 3D model. So basically it is a conversion of 3D models to the physical models, where you are adding the concept of addition of the layers. So and more or less what I'm trying to say is the concept of AME has arrived with the concept of taking the printer. So moving forward, the working principle of additive manufacturing systems, as you know that how this particular AM is works. There are typically 8 steps are there in while saying the working principle or the basic principle of the additive manufacturing system or rapid prototyping or maybe 3D printing process. The first step is in any of the additive manufacturing technology, if you talk about, so the first step is the development of the CAD model. Yes, definitely, because the input is required for this technology is the model. That model is a computer aided design. That means you are developing the computer aided models using certain softwares, that we call as a 3D software or 3D development softwares, like maybe Unigraphics are there, SolidWorks, okay, ProE, maybe Ideas, okay, and there are several 3D modeling softwares that with the help of that, the what type of the design you require, that need to be modeled first, that need to be designed in a particular uh, CAD software. Once the CAD software, one cannot send directly to the machine, because there are certain steps which is essentials to be followed, that we call as the pre-processing steps before sending to the machine. So what are those? One is, second step is the STL conversion. That is nothing but it is a kind of translator or the mediator which helps the compatibility between the software language to machine language. Okay, machine language. So that is what it is basically. So you need some certain compatibility or between the software language to the machine language. So for that, you need to convert that into some neutral format. So that neutral format, there are plenty of neutral formats are available, like maybe IGS, STEP, Parasolid, STL, SLC, SLI. There are various number of translators, we call as translator, because it translates one form of language to the another form of language. So hence it is called translators, or sometimes we referred as standards, different standards of conversion files. So one most commonly used standard is the STL file, that we called as stereolithographic language file, or sometimes we referred as a standard triangulated language. Okay, so this triangulated language will makes the entire model into number of slices. Basically what we do is it divides the entire model into number of slices, that the slices are basically triangles. Okay, it's a triangles, number of triangles with a different coordinate systems, like X, Y, and Z. This is another X, Y, and Z, X1, Y1, and Z1, like this. And another is X2, Y2, and Z2. And this is X3, Y3, and Z3. That means this is a one triangle. Okay, this is triangle. So like this, there are millions of triangles. It is divided. Basically, it depends on the complexity of the products. If the product complexity will increases, so it takes number of divisions of the STL files also be increases. So that means number of triangles also increases. So what basically this triangles helps is it will identify the position of the product in the machines, and as also its corresponding locations. So where it basically the locations with respect to the model coordinate systems. As you can see, you already know in the software there is a model coordinate systems and the part coordinate systems or local coordinate systems. With the respect to model coordinate system, what is the location of this particular triangle or this particular point? So that can easily be identified by the machines through the STL file. So once this STL file conversion is over, then that file transfer to machines. That means the language of STL only can readable by the additive manufacturing systems. Other than the STL, it may not be compatible. So that's why in most of the additive manufacturing systems, we convert that CAD model into standard triangulated language format, so-called STL format, and then we'll transfer into the machine where we use different type of pre-processing activities to check the different types of errors in the products and all. So, right. So once the STL file is ready, that is to be converted into transferred to the machines, where in different types of pre-processing operations are the operations we will carry out. That means checking the error on the file, okay, checking the what is called the connectivity, we call as a topology of the materials, because if there is a topology and the geometries are missing, then it is our machine will not be able to print it. So in order to do so, there are various type of cross checks will be done. Once the cross check is done, that means the machine setup will be carried out. That means to calculate the what is the layer thickness, okay, to be keep to get the then what is the production time it will take to produce the such kind of product. What is what is called as other parameters like file size and all, and the build setup, and what is called as the speed of the nozzle and speed of the spindle. All the parameters are to be setted, and the temperature of the bed, all those parameters are set up in the step number 4. Then once all the the parameters has been set, then it is transferred directly to the machine. Once it is been transferred, then the model is the machines starts to printing the materials layer by layer, and according to the height of the materials, it will divide into number of slices, and that slices is printed one upon each other until the entire model is finished. So once the model is ready, then that model is been removed from the machine setup, and then it is went for post processing operations, where we use to perform various post processing activities, just like to remove some of the adherence materials to the product, to remove the support material, to remove some of the wax which are adhered to the components, or to some coloring and all, for making the product to be very attractive in aesthetic point of view, and all these post processing operations, and finally you will be using that particular products in a of a real application. So this is how the basic principle of AM works, starting from the development of the CAD model to the physical products developed by the machine. Here are some of the applications we find the additive manufacturing systems in major different sectors of the zones, like maybe in aerospace and research areas. I can see various already the industries are already used various additive manufacturing concepts or the techniques to fabricate the products or manufacturing the products. Some of them are defense and research area also, medical and biomedical areas also. We find the applications of additive manufacturing, complicated assembly parts, textile industry even, because most of in the textile industries use the concept of what is called as our additive manufacturing, engineering design applications, wherein we carry out various types of pre-analysis of any design to take the decision that design is whether it is feasible or not. Industrial related activities and design and construction activities and so on. Even in construction area, these days the concept of additive manufacturing systems has been already implemented. Moving forward, the different classification of the AM technology, as we all know, the AM technology has been classified in a various varieties of way, depending upon the various criteria, maybe like physics of the process, source of the energy, type of the material, and size of the prototype. But most of the cases, if you talk about the physics of the process, are more or less similar, where we are, what is called as the same principle. The physics means adding the materials. That is what it is, the basic principle. And the source of energy, yes, of course, source of energy might be different, but in most of the cases we use a laser as a input material as a source of energy to fabricate the parts. And the size of prototype, yes, it depends on the size of the machine, is because if the build size is very high, the larger products can be manufactured. If the build size is very less, the smaller components can be produced. But the only one parameters which vary in almost all the additive manufacturing systems is the type of the material. Yes, definitely, because different type of the materials will make the differences in additive manufacturing technologies. Hence, so as the materials is plays a significant role in additive manufacturing systems, so further this materials is been classified based on the, sorry, the 3D printing has been classified based on the type of the materials. So when we classified, it is broadly classified into majorly three zones. One is called as a liquid based 3D printing technologies or AM technologies. Another is a solid material AM technologies, powder based AM technologies, or the 3D printing process. So we normally seen, or the most of the researchers has been worked in all the three zones of the additive manufacturing technologies. If I talk about the liquid materials or the liquid based AM technologies, the most commonly used is the SLA, stereolithographic process. That is a polymer process wherein the photosynthetic polymers will be used as in a liquid form to get the products. That is a basic principle what we have already seen. And there are others liquid material based 3D printing technologies are available, like DMAC is there, CMET, EOS, okay, stereo system, micro rapid prototyping systems. All these are basically uses the input material as a liquid polymers. Okay, most of the cases the polymer material in the liquid form will be used for to get the final product. But some of the additive technologies or additive manufacturing technologies are present. They are belongs to solid materials, wherein the material is in the form of solid filaments, okay, or maybe granule forms, what it may be. So the filament, so there the material as in the form of solid, so hence it is, they are belongs to what is called as a solid material or the solid material based additive manufacturing systems. Most commonly used is FDM, what we always talk about. FDM is another most important widely used solid based 3D printing technology in most of the industries. Another laminated object manufacturing is also used, but the application point of view, the LOM is very lesser compared to the FDM machine, because it is user friendly machines, 3D technology, wherein you can produce various types of components which can be used directly to the what is called real applications, like something like foil polymerization is another technique is also available, wherein input material is used as the solid based materials. So other than these three which mentioned in the slides, there are some other technologies which is called multi-jet modeling, then is called selective adhesive and hot press, and IBM prototyping systems. All these are comes under the category of solid material based. Then there is another category, that is a third category, wherein the powder material based additive manufacturing systems will be also is a very useful in the industries, or maybe in the current days used this type of additive technology also. But among them, the laser SLS 3D printing technology is being used various applications. And again, it is a user-friendly process wherein we are getting the products very faster. And in the meantime, that can be used directly to the functional products in the real practices, like another 3D printing joining process, okay, binder jet process. All these processes are taking the input material as a powder form to get the final products, like EOS laser sintering is there, then direct cell production casting. The another is called as multi-phase jet solidification. All these 3D printing technologies are basically comes under the powder based additive manufacturing technology. So let me show you, let me tell you, brief about this majorly used 3D printing technologies. One is from liquid side, another is one FD solid side, another is the powder side. So coming to the liquid side, the most commonly used is the stereolithographic method of 3D printing. And that is what commonly we call as a SLA. It is developed so early back, even in 1980 itself. So the concept of this technology, and basically it is a ultraviolet laser will be used for developing the product. Okay, so and photopolymer resins will be used. So this photopolymer resins are basically a liquid format. Okay, so liquid format will be used for photopolymer resins, and these liquid resins are kept in the particular chamber, and the products are and the laser is transferred over the what is called as in the machine zone. So when the laser is transferred, then the polymer resins or the liquid resins will get melts and get solidifies, and then it starts printing layer by layer upon each other. So once one layer is finished, the table will move downward direction to get the settle for the second layer, and then finally once the entire model is ready, then it will be removed. So most of the photosensitive polymers, and we use in the case of this particular technology for making the finished product. So let's see how this particular technology will be works with this video. So is this sound is audible?
Yes, sir.
Okay.
It's okay, sir.
So this is what basically is a liquid resin systems. So here, so this is the liquid polymer resins, and this is the components. It is a lowered the build platform.
Sir, video has no sound, sir.
Okay, 1 minute. I'll just I'll this got just I'll share in a different way. Share the sound. Yes, now I'll share. I hope now it is coming.
Yeah, now it's okay.
Uses a UV laser to cure liquid resin into
So this is a
plastic.
liquid resin.
Upside down or inverted stereolithography
Okay,
is
then
the most
it is
common
a
SLA system.
wiper
Depending on the
systems.
machine, resin is either poured into a tank by a user or dispensed automatically from a cartridge. At the beginning of the print, a build platform is lowered into the resin, leaving only a thin layer of liquid in between the platform and the bottom of the tank. Galvanometers direct the UV laser
This is
through
a
transparent
laser,
window
UV
at the bottom of
ultraviolet
the resin
lasers.
tank, drawing a cross-section of
So
the 3D model
it is
and selectively hardening
automatically the
material.
cross sections.
The print is built in consecutive layers,
and finally
each
we
less
get
than
the
100
product.
microns thick. When a layer is complete,
One layer
the
is
part
complete,
peeled
then
from the bottom of the tank,
again the bottom
letting
of the
fresh
tank.
resin flow beneath, and the platform is lowered once again. Originally developed in the 80s, SLA was confined to large industrial machines until recently. Today, desktop stereolithography offers affordable, high-resolution 3D printing that fits conveniently in your workspace. SLA allows for the use of a wide range of materials with diverse physical
So
properties.
finally, the products has
Whether
been
you're an
removed.
engineer, product designer, sculptor,
And there are
jeweler,
some
or
of the
dentist.
supporting materials which later stage we remove as in post-processing stage to get the final products. So moving forward, the next technology which is the most commonly used is what is called as the FDM process, that is a fused deposition technique, wherein the solid material will be used as a materials to get the products. It is comes under the category of solid based model. Right. So here this model has been developed, or this technology or the machine has been developed by Stirasis, is one of the known company in USA. Right. So and so here the filament windings will be used, or the filament, the material is in the form of filaments as a wire form, is fed into the what is called as a chamber or the heating chamber through the rollers. There will pass to the FDM head, wherein various heaters will be provided to get the products or the filaments into liquefied form. So when the wire roll is entered into the what is called as a head, then the materials get liquefies, and then the nozzle will starts to extruding the material, or maybe depositing the materials over the surface. So again, similar concept here, again adding the materials layer by layer. Once the one layer is over, then the table will move downward direction, and the second layer will start, and the third layer will start, and so on. So until the entire product will be developed. So more or less the concept will be same, but the material is different. That means the material here used as what is called as the filament based materials that are in solid form. So various types of materials will be used, like one is called ABS, that is what it is called, acrylonitride, butadiene, styrene, plastic. It is a kind of plastic, PC, and there are combination of the different polymers, plastics, and PC and ABS blend to get the higher strength and all. Depending upon the application point of view, the material will be used. Then ABSI for stabilize and translucent, like whatever the we have car lights and all, the color lights which we use normally use in the various cars, that is are made by ABSI. So then in some of the investment wax also will be used in the case of FDM process. Let's see, I'll show you different materials in these properties as well in the coming slides. So just I want to show the working principle how it is.
Material extrusion, also known as fused deposition modeling or fused filament fabrication, is one of the most common and widely available AM methods. Material extrusion systems use an extrusion head with a nozzle to deposit build material onto a build platform. During material extrusion, a filament is fed through
This
the
is
extrusion
a
head by a
filament is
drive
fed
roll
into
and
the
past a heating element.
through the extrusion
The material
process,
liquefies
and
and
then
is
it
then
is through the
deposited by the
nozzle,
nozzle onto the build
and
platform.
build platform will be
The
there, and
extrusion
it will
head moves
deposit
horizontally to
layer by
selectively
layer.
dispense a material layer in the shape of the desired part onto the build platform. The build platform, which usually moves vertically, lowers so the nozzle can dispense a new material layer on
See
top
how
of the
the
first
one layer
layer.
is completed, then the
Each
table
layer
will move downward
solidifies and joins
direction.
with any additional layers. This process repeats until the final product is complete.
And then another very important methods normally we use in most of the industry is the selective laser sintering. The concept of using a sintering process by sintering the powder materials through the laser, or the heat source through which the development of the sketches or the products will be done here. So as usual, same concept in this particular technology as well, wherein we there is a bed, but the material is in the form of a powder. This is what actually is a powder material. So in the earlier case, it was a filament form or solid form, but in this case is a powder form. Various types of powders in the form of polymer powders or metallic powders also used. If the metallic powders are there, then it is called as a metallic SLS 3D printer. If it is a powder, polymer powders are using, that is a polymer based SLS and all. So depending upon the type of the material, powder is being used. And again, same, the concept is same. The sintering, the principle here is a sintering process where you are sintering the powder particles to bind the powder elements one upon each other. Similarly, the input source will be transferred over the surface through at which you are going to bind the powders. So that zone will be the binding layer by layers, and then once the layer is completes, the table automatically will move, and the wiper or rotated arm, what it will do, it will wipe the unwanted materials and make the flat or maybe putting the what is called as the powder over the surface of the sketch. Then again the heat source will be provided, then the required sketch or the hatching, what we call as hatching, will be cued, and then it will bind with the previous layers. So on it will be carry out to get the final products. Let's see the video of the same.
Motor designs, air ducts.
Okay, so you see, I've seen that how particular 3D printing technology of SLS is been used to make the products of real practices. Now coming to our main zone of the talk is the printing materials. As we have seen that three different concept of 3D printing technologies uses the three different way of materials, like maybe one is a liquid material, another is a solid material, there is a powder materials. So as such, when we differentiate or when we classify the 3D printing materials, there are basically again based on the type of the materials. So like maybe solid based materials, liquid based materials, and powder based materials. So among the solid based, liquid based, and powder based materials, there are different types of the additive manufacturing technologies or 3D printing process will be used for the respective materials. Like for example, solid, as we have already seen with the FDM is another important the process which used the solid based material. LOM, that is what a laminated object manufacturing is a technique which uses the solid based materials. And SLA is a liquid based, polyjet is a liquid based, and then metals, SLM, selective laser sintering, then selective laser melting, EBM, electron beam melting, binder jet technology, it comes under the polymer side. Selective laser sintering is also considered as polymer side, where the polymer powder will be used as a materials, and high speed sintering process, where it is where very faster way you are going to manufacture the products. So when we talk about the few of the materials, because the material is a vast area, different types of the materials we use in 3D printing technologies with the different varieties of grades as well. So now my focusing on only few of the materials which are most commonly used in 3D printing instead of going the grade wise. So I'm just showing you some of the important materials which are specifically used in the 3D printing technologies. So here I'm listed some of the solid materials which normally used in most of the additive manufacturing system is called as plastic based materials, that is in the form of wire form, layer adhesive coated papers, plastic, simple plastic, metal laminates, and so on. Liquid based materials, normally we use photosynthetic resins, normally in most of the cases clear resins, engineering SLA, that is selective laser acid, then lactic acid, then tough resin, that is ABS like, then durable resin, that is PP, heat resistance resins, etc. That means basically in the liquid materials, resin formats of liquid materials will be used as a input materials. Powder side, polylactic acid, glumatic, then thermostatic elastomers will be used, polyethylene quinones, polycarbonates, and so on. Some of the metallic materials are titanium, stainless steel, and aluminum, tool steels, and etc. And even some of the other materials like ceramics, sand, and somas, elastomers, etc. will also be used in most of the additive manufacturing technologies. Let's see one by one the different materials which normally used or most commonly used materials in the 3D printing. The first and foremost is the plastic. We all know most of the 3D printing technology use the plastics. So various types of plastic materials are available for printing of the 3D printing. or the objects through the 3D printing. And but the it is available means I cannot use depending upon the type of the application, type of the complexity of the products, and also the need of the product. The corresponding, the plastic material will be selected for that particular product. So mainly the depending upon the types and different 3D printing process, we select the type of the plastic materials to get printed. But most of the cases, what we basically use a thermostatic and thermoplastic, plastic and thermosetting plastics only we normally use. In most of the 3D printing technologies, in that the first is the ABS materials. As we all know, this ABS is a acrylonolite butyrene styrene. So this is a very most commonly used plastic material in the form of filament as well as in the granule form, will be used in making as a 3D printing materials in 3D technologies. So why? Because it has a good impact resistance properties. Wherever you need the good impact resistance properties, there one can use the ABS materials. And also it provides a good strength and moderate flexibility of this type of materials, and easy to extrude from the printer nozzle. That is one of the plus advantages of this particular type of material, that is ABS. As you can see in this figure, it looks like this in the form of filament as well as sometimes granule forms. So what is the temperature range it can withstand is around 210 degrees centigrade to 50 degrees centigrade in the high side. But most of the applications, like I can see the printing of plastic, like automotive parts, moving parts, musical instruments, kitchen appliance, electronic housings, various toys, etc., where this ABS material will be used. And other applications like traditional manufacturers, like the plastic wrap, water bottles, cups, okay, and so on. So these are the applications where this ABS material will be used. Depending again, this whatever the applications has been shown, where you require some properties, based on that properties, this particular material will be used. More or less, this particular material is being used in most of the applications, but wherever there is advantages are there, there are some disadvantages. Yes, this material is having a certain amount of disadvantages, a certain parameters of disadvantage is that means one cannot use this particular filament or the materials for the home users, because it has a high melting point that needs to print on a heated surface or bed. Also, sometime when printing the ABS, sometime we get a unpleasant fumes that is irritating to the operator as well as the environment of the process. So that makes the various types of environmental issues while printing the materials. So that is one of the important, the most commonly used materials in the additive manufacturing systems. These are some of the branches of the components which are produced by ABS plastic. As I already told, this is a light which is made by what is called, this component is made by ABSI. It is a special type of the blending of the ABS with some other components to make the enhancement of the strength. So like ABS pure, ABS M30, these are covers, and this is the materials of AB ESD7. There are various grades of the ABS used for making the different products for different applications. Next is the PLA. So the PLA is another important what is called as the material which is most commonly used in most of the applications, are in the most of the areas. So why? Because it has some of the advantages, like it has a good impact resistance, again a good strength and moderate flexibility. Then it is a very easy to extrude the printed nozzles. So that is one of the what is called as the beauty of this particular materials. So obviously the temperature which it carries is around 180 degree to 230 degrees Celsius only. So it looks like a filament form. Sometime we may get as in a granule forms also. the PLA is also used in granules. So which particular methodology or the technology will be used for these materials? One can use for, if it is a filament side, one can use for FDM process. If it is a granule form, one can use for if it is a powder form, one can use for SLS. So there are applications of this PLA materials, most probably it is used in, medical stitching. That means in medical applications, where including surgical implanted pins. The pins are manufactured by this PLA, and some of the rods, surgical rods, which being used in what is called as in the medical applications. Some of the small screws, some of the mesh, or some of the consumer items also will made by using this PLA. And some other applications like food packaging materials, disposals, tableware, or the diapers, and all are manufactured by this particular PLA. Why? Because why this particular PLA has more widely used, because of the biodegradability. It is sometimes we referred as environment friendly, the materials which is which is made from the natural resources like scratch, corn scratch, and all, right? So by using the starch of the oil or the corn, so it is extracted and get develop the material. Sometimes we refer this as a biodegradable and environmental friendly materials. So that means, hence, as such, this material is in biodegradable and environment friendly, so no harms fumes will be generating when it is printing in the FDM process. Produce from street arm with heated, easier to work with the compared to ABS, because ABS is having a one of the limitation is that when it needs a very larger heat of to melt it, and also some of the fumes it generates, that makes the process is environmental prone, or maybe it is not good for environmental conditions. Now compared to ABS, the PLA is less prone to the wrapping, obviously, yes, because it is environmental friendly and it is obtained from the natural resources. Hence, that the PLA is the most commonly used in most of the applications. The next material is the PET. That is what polyethylene tetra triptylite. That is what it is, triptylite. So, so this is also one of the most common used material. That is what it is. Why? Because it is compatible with the lower printing temperature. That means at a lower temperature than for faster production process. Humidity and chemical resistance capacity of this particular metal compared to PLA and ABS. High transparency, one can go for food safety, means can be a food safe in this particular material. That means if you are placing any food in this particular boxes, or maybe any materials which is made by PET, so then your food is not going to be poisoned. So it is a what is called as a food safety materials, wherein your food is in very good conditions. So what is the temperature range it can carry? That is approximately 210 degrees centigrade to 230 degrees centigrade. The application is waterproof applications, snap fit components like the cups and plates, etc. As you can see in this figure also, there are various applications of what is called as the PET plastics, okay, and foods containers and various kitchen utensils also made by using this material. So one can say that this PET material is basically used in most of the consumer side of the food industries. So that is a beneficial side, because if you are keeping your food in a particular box of made by the PET, so your food is not in a damage, it will not be damaged, or it will not be poisonized. So, and this PET is also in the form of granule form and as well as in the filament form. Then it is a solid based materials. So hence the FDM process is the best suitable for this material. Next is the PETT, that is an additional grade of the PET. Okay, where there is a trimethylamine is a L component is added into the PET to make the the glassy filament type of structure to the filaments, like glassy filament is called as a T glassy filaments. So that means it looks like a glassy type or glass type kind of thing, but it is having greater strength compared to the PET. So non-biodegradable, again, this particular material is developed by the some natural resources. High transparency, yes. So when you made with this, it is having a transparency materials where one can see the products which are inside the box or something like that. That means transparency is there. And again, this material is also is best suitable for the fooding applications, and more or less the temperature is similar compared to this. So as such, the properties of the PETT and PET is similar. So one can expect that this particular material also will be used in FDM, because it is in the filament form, will be used the FDM process, and for various applications like food. Okay, the measure will be used for various food containers and other kitchen utensils only, because as it is a biodegradable, and so hence it will be preferable to use in the case of what is called as uh, fooding applications. So the next is there are some of the advantages we obtain, we get by this particular methodology is this material is very strong and flexible. Okay, then the biocompatibility, as we all know that, and do not wrap or sink during the preparation, and do not absorb the moisture and the water. So that is the plus points of this material. So hence, with this plus points, this component, this material will be used in food applications. So again, this material will be printed by FDM process. Another important plastic materials which normally we use in the 3D printing applications is the nylon. We all come across, we all know this about materials. The nylon is the most commonly hearable as well as usable in most of the industries, and in the daily lives we used to use or feel the products which are made by nylon. So why? Because nylon is a material which is very strong in nature, durable, and light in weight. That is a advantages, and also tough and partially flexible. Okay, that is not flexible in nature, but it is partially flexible. Heat and impact resistance, when there is a resistance of impact force also can resist this particular materials. And very complex to be print, means various complex component is there that can easily be able to print by using the nylon. And how again, nylon is in the form of granules or maybe filament form. So therefore the nylon materials can be printed by using the FDM process. More or less the temperature is also almost in the similar range of 210 degrees centigrade to 50 degrees centigrade in most of the plastic materials, having the similar range. But in a higher side it may be go according type of the filament is added. Again, addition of the different materials to get the grading of the different grades of the nylons have a different ranges of the temperature withstanding. So as such, this material is a solid base. So FDM process will be used for printing of some of the components. As you can see in this figure, these are some clips. These are some gears or some of the plates, some of the structure, which is a vice structure, or the casing structures are printed by using a nylon. So if you talk about the applications, wherever you need a greater strength, flexible properties and durability you needed, in that case we should go for using of nylon materials instead of ABS and the PLA. And consumer products like tools, mechanical components, machine parts, structural parts, containers, and many more will be developed by using this particular nylon. So that means the nylon products related to tools and all can be directly manufactured and can be used in the direct applications. Next is a PVA. This is another plastic which normally used in FDM process. That is what polyvinyl alcohol. So as the name itself is nothing but it is something like PVA. So that typically used in support material. This material is not being used for the making the printing the main part, but it acts as a support material. It will be used as a support material in most of the cases, because some of the halo components of the products needed some support materials. So that support materials for after producing the parts will be removed and super finish the products to make the good quality. Somehow the support material will be is needed, or support materials will be used for producing. In such cases, the most of the support materials will be used by PVA. Okay, and when printing the ABS and PLA, so that means it is will be used in combination with the ABC and PLA. And the PVA works best with the printers that have a dual extruder. That means you need to have the extruder. There are two extruders will be required in this case, because one is called as PVA, another will be PLA. So that means combinedly it will be printed, right? So whenever there is a support material is needed, that will be printed by PVA, and whenever there is a main components to be printed, that will be printed by PLA. So okay, so that will be works using a dual extruder. And again, this particular PVA is a biodegradable, non-toxic material, and that easily dissolves in the tap water. Okay, that means why? Because we are removing the support materials after, and we'll wash it the entire product into and water, or maybe something, any other post processing operations. So this material, if you drop in water, it is automatically dissolves in the particular water. So then it is easily biodegradable. So temperature is bit low compared to the what is called as the PLA and ABS. Hence that's why it is used as lower temperature applications. Another is PVA applications, like it is used for thicker in the paper adhesive materials in personal hygiene products as a mold release agent, or freshwater fishing pots products, etc. So but some of the what is called as important prawns and important crons related to this material is, it is a biodegradable, non-toxic, water soluble, good durability is there, make otherwise difficult printing easy. Okay, and attracts water easily. Am I audible?
Yes, sir.
Yes, sir. Yes, sir.
Okay, okay, and attracts water easily, and can difficult to source compared to other materials, and high cost compared to the 3D printing materials. So another material which is again usefulness is the sandstone filament, that is the addition of PLA plus brick. So basically this material is also is well used in most of the applications, and it's a blending of PLA plus brick materials. Okay, it's a blending of PLA plus brick. So brick is in the sense, it is in terms of the coating kind of the brick materials over the PLA to make the feel of stone colors and the textures. So there are some this particular material will be used for and adding the surface characteristics, like extrusion or temperature during the printing process. Approximately 165 to 210 degrees Celsius is the temperature it can withstand. And the application point of view, if you talk about, if you see, this can also be used in various applications, like wherever you are adding some color and structures to the components, and like architectural monuments and the components where you are adding some of the textures or and colors to the products for making decorative items. There we use this kind of filaments or the materials, like you can see in this figure. This is also available in the filaments form, and the materials which are printed already by most of the architectural display models or the ornamental models. There is another is wood filament. The wood filament is basically used as another materials. Normally, this is not a wood filament, but it's basically is a PLA with coated with some wood structure, out color. Okay, in most of the cases, the peoples will confuse that it's a wood filament, means it is made by wood. No, it is a filament, PLA filament. It's coated with some wood texture. So that's why again this is also useful for making the products of functional products and some of the what is called toys of the kids. So applications is wood filament for no other than their creativity only purpose, and for decor items, ornament boxes, tables, chairs, then other toys for the kids is made by using this particular wood filaments, wherein the customer will feel that this is basically made from the wood, like that. So the texture will be given to the over the surface of the PLA or maybe ABS or any other materials to feel the wooden properties of the materials. So some of the cons are there, like it's a weaker, obviously, because it is a PLA materials. Instead compared to PLA, it is again weaker because something coating will be done over the filament, lesser flexibility, tensile length, okay, and strength, easily breakable. That is one of the weakness of this particular material. So whenever these applications is not needed or needed, in that case, the wood filament is not preferable materials. So this can also be printed by FDM process. Next material is magnetic iron PLA filament. So wherein the as a magnetic iron is a kind of filaments. It's like look like a magnet, okay, iron particles which are infused in the what is called as PLA, or reinforced in the PLA with some powder irons, okay, some of these iron particles or iron powders. So these particles will give the 3D parts and their grainy gunmetal type finish, okay. So wherever you are producing this kind of monuments, just see in the figure, this kind of monuments are produced by where you want a look of like iron particles kind of look you want to want. In that case, this particular material will be used. So the temperature is approximately 195 degrees Celsius to 220 degrees Celsius. It can withstand. The applications again same, educational tools or the magnetic is making for various DY projects, sensors and educational tools for demo models for the students to show, and wherever you are going to show the iron particle type of components for the students. But apart from the bronzes, there are some limitations of this material. That is what nozzle temperature needs a fine tuning, because here this, as it's iron particles, is a powder materials where you need some temperature need to be readjust, because this iron particles having a melting point different compared to the PLA. Okay, inflexible sometime, it is not a flexible material, heated but not needed here, and material is expensive compared to the other popular filaments, obviously, because we are adding some other an element which makes the enhancement in the product. The next metal is conductive PLA and carbon fiber. As you all know, this is very most commonly used materials in most of the electronics applications. Okay, it's like conductive PLA. That means where the PLA is made as in a conductive manner, and that means conductive materials. Different types of wires. You can see these are the wires, connection wires, connector wires, LED wires, LEDs, circuits are made by using this particular materials. So this also can be printed by the FDM process. So like create circuits, LEDs, sensors, and various low voltage projects, etc., will be carried out or will be done by using this conductive PLA. There is another important material, that is a carbon fiber 3D printing elements. So where here also this material is a very useful materials in these days, because very high strength materials will be wherever the application is needed. In that case, the carbon fiber PLA will be used, where the carbon fiber is reinforced in the PLA, that makes the composite material, and to produce a high quality and strong objects where you need a very higher strength in the object. And most of the like racing car and some of the aerospace applications or maybe automotive applications, where we use this type of carbon fiber 3D printed filaments. So here it's a wherever you need that kind of this, like protective casings, some of the casings of any motor, casings of any wheel, or casings of any product where you need a higher strength. In that case, this material will be used. and many at higher durability users. Yes, where you need a durability is major concern. In that case, so carbon fiber 3D printing materials will be used. Okay, so moving forward, next is, okay, so next is flexible TPE and amorphora filaments. This is another plastic materials which we use in 3D printing as a material, that is a thermoplastic elastomers. Okay, that is what flexible TPE we call as. These are elastomer materials. It's a wax kind of materials basically, and this material also used for making various household appliances and automotive sectors in most of the cases, and popular kid toys and wearables and smartphone cases, etc. We normally use this flexible TPO and amorphora filaments. And next is commercial medical applications like medical suppliers, weather seals, and then for windows and doors, electrical installations, and soles of footwears, all are made by using these elastomers. Okay, so next is the amorphora 3D printed filaments. Yes, this is a very durable material again. It's like a very good materials for printing the lightweight materials and having a higher resistance. So all toys or dummy models are the decorative models of various materials, various products will be developed by this 3D printing materials. Sometime we get a very excellent strength in this particular amorphora 3D printing filaments, and high flexible also, and as well as durable also. And moving forward, the metallic filaments, whatever I have shown you, those are all plastic materials or filament form, which are used most probably in a FDM process to get the products. Some of the metallic materials or the filaments are the materials used in printing of 3D printing components. One is the most important filament which we used in the metal side is the stainless steel. We all know stainless steel is a various wide applications in most of the industries and most of the applications. So hence there is a grade called as 316L stainless steel, which is most commonly used in most of the applications, and and most affordable materials in 3D printing zone. It is also available in what is called as filament form as well as in the powder form. Right, applications is for tooling purpose, where you are making the different mold and core cavity, jigs, fixtures, molds, and other functional parts, where durability and resistance are very important. And for components of what is called as the corrosive environment, where you want to corrosive environment requires very high strength, mechanical strength. In that case also, this type of stainless steel print material will be used. For medical also, it can be used. Automotive also can be used. Aerospace industries, and to create the functional prototype and the series productions. So in these areas also, one can use these materials. So these are some of the branches you can see wherein the metallic filaments can be used for printing. This is what actually what I told. There is a tooling industry where one can develop the stainless steel mold by using a 3D printing, and maybe FDM or maybe SLA. So this is a component. This is a one more component. This is a one more component. These are all made by printed by a 3D materials. Another stainless steel of higher grade is 17P4 pH. So basically, it is a 17.4 pH is a stainless steel using fused filament fabrication. That means FDM 3D printing technology. It is just with a grade of a higher percentage of the pH, and this for basically corrosive environment and require high mechanical strength and the hardness, isn't it? So what are the applications we may find? That is aerospace, aviation, automotives, and medical. Most of the cases like tools and jig fixtures of all areas, one can use these materials to print the objects. So for example, if you see, this is the object which is printed by the stainless steel 74H pH, and this is also available in the form of filaments and the powder form. So this is the one material you can see, and this is the turbine blades. and the gears are manufactured by using this particular stainless steel or printed by stainless steel. Another important metallic powder, which is most probably available in powder form, that will be used for SLS process to print the materials. That is aluminum with a different grade of AISI 7 mg 0.6 material. And like it is a like as it is, this aluminum is 90%, silicon is 7%, magnesium is 0.6% in this. So this material is available in the powder form and can be printed by using the selective laser sintering, and it is have a good mechanical properties and can be used for a part subjected to high voltage. Okay, and this is a durable and lightweight, very low weight, and effective in areas where the strength and mass ratio as well as good thermal properties are required. So whenever you require this property in any of the applications, so one can use this particular material as a 3D printing materials for your product. But application point of view, more or less same as for the stainless steel. Here also one can use this material for printing the various components of the various applications like aerospace, aviations, automotives, and the medical industries. Then some of the tools and tool jigs and fixtures, and some materials which carries a higher loads. As one can see these figures, different types of figure components which is manufactured by aluminum materials that is printed by SLS process. Next is the metallic powder, that is a titanium AI4V. We all know this is a very common materials normally we use, which is also a powder material which is available in the form of powder form. So hence one can use only SLS process for making this printing this material. So this is having a titanium of 80 to 90%, aluminum is around 5 to 6%, and vanadium is 3 to 5%, 3.5 to 4 percentage. And what is the beauty of, or what is the plus advantages of this material is having hard and highly resistance to the oxidation and exit. That is one of the major advantages of this material. So with these advantages, one can handle or withstand this material up to around 1660 degrees centigrade to even 30 to 60 Fahrenheit. Okay, so that means up around 1500 to 1600 degrees Celsius, it can withstand the temperatures. So that means again, it's a very lightweight compared to the other stainless steel and other aluminum. So hence this also used in various types of applications like prototype development for aerospace, automotive, tooling and fixtures, and so on. Wherever you need a component with a higher strength or a higher loading carrying capacities, like as you can see the turbine blades or this complex structure and these gears and some other materials which needs a very higher loads in the real applications. Such materials or such components can be printed by using titanium alloy. There is another called as copper, is another metallic powder which is used in what is called as SLS process for printing the different various types of materials. And basically this copper normally we use for thermal applications and electrical applications only, because where the copper is a good conductive material, so hence it will be used for thermal management applications most of the cases. As you can see in this figure, these are the pins is developed by copper. This is the casing which is developed by the coppers. Okay, and this is another component which is developed very complex structure. How see, this is a very complex structure which one cannot manufacture by using what is called as any our conventional machining systems. So casting is the one option. Yes, that's why the best replacement is the additive manufacturing, where the complexities also can be achieved. So most of these copper components will be used for the thermal management applications. There is a metallic powder, that is steel bronze, is a blending of BR. That means bronze and the steel. The blending of the bronze and the steel also have the significant advantages, and it is used in various applications due to the strength and the resistance. Here the bronze material in the steel, adding the addition of the bronze in the steel makes the strength increment to the steel. So to get higher strength, wherever there is a higher strength materials is required to be used, in that case normally this material will be used. But most of the cases, this material will be used for decorative items and ornaments. So where like, jewelers or sometimes decorative items where we're keeping the products for showcase purpose to show the visitors. Another metallic powder, that is a bronze 3D. There is another material which we again, it is a 90% of copper and 10% of tin. So this is the combination of the material. So this material is used for again for jewelries applications where different types of very small components are manufacturing by these materials. Okay, almost all the jewelers like rings, or maybe like pins, okay, or the any in locket or any jeweler particles are been manufactured by using these particular materials. Another powder material is stainless steel 316L. It is in the powder form. The previous one which I have explained, it was in filament form. The similar form which is in the powder form, and this also one can use for making use of different types of stainless steel products where you require a higher strength. Okay, maybe a tooling or molding or injection molding purpose, automotive or aerospace applications also one can use this material. Another is a polymer powder, that is a nylon PA12. It is an additional grade of the nylon for durable materials. Okay, and this material is also is a polyamide 12 of nylon, and this is very powder form. It is available. Hence, the technique which is used to print this material is the selective laser sintering. So here also this material is having a good mechanical strength, okay, good properties with this nylon material, and having an advanced additive manufacturing can be substitutable for injection molding parts for plastics. So this can also be used for pharmaceutical and medical fields applications and packaging industries, because as it is a nylon. Okay, so packaging industry and sterilized films can be manufactured by using this. Some of the blinches of the figures, as you see, that is printable by nylon PA12 using SLA process. The another material which is a biodegradable material is a polymer powder, that is what PA11. It is a polyamide 11 grade. It is based on castor plant, castor seeds. Okay, it has been extracted from the castor oil. So hence, as it is extracted from the nature, so hence this is called as a biodegradable polymers or biodegradable materials. So obviously, when there is a biodegradable materials, one can use for medical applications. Okay, one can use for hinges, one can use for some support materials, one can use for some other critical components which can be used in the medical applications. Okay, so as such, this can be used for various medical as well as the exterior applications of automotives as well. So this is a biodegradable materials. Another materials which is a nylon 3200 glass field. So again, it is a next grade of the nylon materials, wherein you are adding glass fields as a filler materials to get a higher strength components in the nylon side. So when we see the nylon, there are various grades of nylons are available. So I was trying to gather the different nylons, but the few important applications of the nylon materials I have gathered here and I'm exploring here. Okay, but if you talk about the nylon grades, various types of nylon grades, various types of properties you will obtain for the different grades and different applications also. So here the glass filled polyamides is basically glass finishing structures is added in that to get the glass finishing structures to the surface of the component and also to increase the strength of the components. These are some of the applications where this metal will be used. Okay, and these are some of the properties this metal does having. One is called lightweight material, low coefficient of friction, high tensile strength, and so on. Okay, with these properties, these are some of the examples in the real practices already made by this particular nylon 3 to 100 glass field. So this, you can see the pictures. These are the the materials which are printed by SLS technology with the help of nylon B12. Another powder materials which is used called wind form. Wind form XT 2.0. So wind form is basically a very high durable and high strength materials. Specifically, this material is used for sports applications. First, like like headlights cover of the sports car, the casings of the forced engine car, and this is for a prototype model of the aircrafts, and these are the dome covers of the some of the components which very require very higher strength. So therefore, and these all materials are undergoes under the wind. That means when it is travels with a very high speed, it is acting with a very high wind velocity, right? With a very wind high. So under those circumstances, it has to withstand that capacity of the forces. So for that purpose only, the industry has developed a material called wind form XT 2.0. So this basically high-tech material for additive manufacturing chosen by those working for motor sports areas, which allows the applications fully functional as well as bench testing, wind tunnel testing, and racing on the track. And it is best perfect for functional applications not only in the motor sports field but also in automotive, air components, UAV, unmanned aircraft vehicles, unmanned aerial vehicles. Okay, so then aerospace and designs. In these applications, this material will be used. Next is the other materials. In addition to the filaments, in addition to the plastics, in addition to the metals. So there is another zone of materials in which the 3D printing technologies using the materials are that is sand 3D printing. That means the sand is another materials is used as a printing material for printing the different sand products. Okay, most of the cases, the sand 3D printing or silica sand is used for printing the materials. In addition to the other materials also will be used. And this will be used for making the core and cavity of the molds. Okay. And most of the applications used for is a core and cavity. And this is in the form of a sand. Okay. And it is having some different properties to withstand the capacity. Like these are the some of the samples we can see where the sand casting or sand printing is a technology which is used for printing these materials. Another is a TPU 92A elastomer. Yes, you can see this is a spring type of spongy materials. When you press also it will come again against to original positions, and press again, release again, it comes to result. This kind of materials is made is a basically TPU. It is a elastomer. It is basically elastomer. It is a kind of polymer materials having a similar properties of elastomer, but they are very flexible and room temperature, but still remain dimensionally stable. Yes. So when you apply a force, okay, it will press, and when you release it, comes to the original position. So this type of very high elastomers, high quality elastomers will be used in making the damping elements like bumpers, bellows, soles, and handles and hoses of different components, casings, etc. So this is a one component. You can see this is another component, and this is another component which is made by TPU 92A elastomer. So this is the other type of materials. Another materials is ceramic. Is a one more widely used 3D printing and the ceramics, various types of ceramics. As we all know that ceramics is a very high heat resistance, insulations and corrosion resistance materials, where one can withstand higher temperatures, and very insulating materials. Wherever the applications of this kind of applications is needed, there the ceramic materials can be printed by using a different products. So some of the blinches of the figures you can see. But in the side of ceramic printing, there are various types of ceramic printing technologies are available. So if it is a slurry based ceramic is there, one can use stereo lithography, digital light processing, two photon polymerization, inkjet printing, direct link writing, etc. Powder is there, then three-dimensional printing, laser sintering. Okay, so then laser melting is there. Solid waste is the laminated object manufacturing and the FDM process. So the manufacturing technology will be same, but material is be different. Okay, so what I'm trying to saying in every slide is manufacturing technology is same, but materials are different. Okay, then other material is a cast form, is a one of widely used in most of the casting applications. Okay, in casting application, it is basically PS and SLS. Okay, PS SLS, that's why it is called polystyrene, used by SLS process, is kind of wax materials. Okay, and the styrene based expandable pattern casting material it is, and compatible with most standard foundry processes. Only foundry applications this material will be used, and it is the best prototype materials for metal casting, basically metal casting purpose. I can see this engine casing is manufactured. This engine casing made by cast form. This is a cast form materials. So engine casing is made, and later the material will be deposited in this, and finally you get the what is called engine casing which you require. And to low to medium production runs without tooling activity. Another is SOMAS 201. So this is again a rubber and elastomer flexible materials, which is being used in specifically stereolithographic process. So it is in a liquid polymer resin, okay, which is being used for developing various types of functional products, testing applications, okay, and some automotive traditional thermoplastics also can be manufactured, as you can see in these figures. So these are the varieties of the parts one can manufacture by using this particular materials. And the process which is used to print this material is the stereolithography, that means SLA. Coming to the future directions, what are the future directions in this particular area of 3D printing materials? So there are various zones one can work in this particular work of the 3D printing materials. I covered almost all the materials which are being used in 3D printing for different applications. But when we see, the material is a very broad classification, and with various grades, having various properties, and various temperature ranges, various applications. But I was tried to cover the most of the common materials used in 3D printing 3D printing applications or 3D printing technologies. So coming to the future directions and challenging, what are the field wherein still the work is left or to be explored by the researchers? They are advancement in the additive manufacturing. Yes, one can just recall when I was shown the classification of the AM technologies. Most of the technologies are the traditional way of physical process, right? So hence there is a need of advancement in the technologies where one can make the process to be very faster way. Obviously, these additive manufacturing systems are very faster. That's why it is called rapid. But still, there is a lacuna in the each and every processes that need to be enhanced, that need to be explored, and that need to be advancement to make the manufacturing system very faster. Currently, all the AM is more limited to smaller in quantity. Yes, obviously, because as we talk about smaller in quantity means we produce the most of the functional products and for preliminary analysis only. But these days, the industry has started for larger productions also, because why? Because it is a larger is a challenging field, because this is a very costly process wherein the cost of the products will be increases, right? But wherever there is a need of the actual products is manufacturing by the additive manufacturing, but still there is a challenging field of making the additive manufacturing process for a mass production zone. So that means advancement in AM technology is needed again. Coming to our our topic, that is a development of new materials. As such, I covered most of the materials which are used in additive manufacturing systems, and try to show you the its material name, the process through which can be printable, and applications, and some of the samples available real products for respective materials. But still there is a scope in developing a new materials in the area of additive manufacturing systems. That is what it is, a new polymers, different new polymers, non-polymers also is there one option. Biocomposite materials, yes, that is very important. Some of the already is existing, like whatever I have shown you, some of the biocomposite material like PLA is there. Okay, and that is what PA12, okay, nylon P12, all these materials are PLC is there another, okay, and PA, HA, and all our materials are biocomposite materials, where the materials are developed by adding the two materials. Another area is a green composite filaments, where one can make the filaments or solid based materials in the form of filaments by using natural fibers. So these days natural fibers are waste materials which are throwing to the agro waste, that can be utilized for making use of, making a filaments for FDM process. So in this area I'm working, basically my students and researchers are working for developing the jute uh, jute plus PLA based material, and coir plus PLA based materials for additive manufacturing applications. So this is a new area. One can think, one can to work in this particular zone. So very less work in this particular area. Hybrid composite also another area where the development of new metals for additive manufacturing systems for different applications point of view. In addition to that, there is another area which is basically authors have not taken into consideration, is the environmental aspect into consideration, that is green additive manufacturing. You might have seen green manufacturing technique or maybe a lean manufacturing and all, but as such a very less work in the area of green additive manufacturing, wherein environmental issues related to the printing of the materials or the processing of the materials into consideration, and also energy cost, that means the process use the energy consumptions, and the total life cycle products cost also need to be consideration while studying its performance of the process. So this is another area one can think of to work in this particular green additive manufacturing or green 3D printing, etc. So with this, I conclude my today talk, and I hope I covered almost all the materials which normally used or most commonly used in the additive manufacturing systems. So thank you. Any query is there? So let me know from the audience.
Please, participants, if you have any query, you can ask, or you can post in the chat box also.
I'm expecting more questions.
Yes, please, participants. Okay, sir. Thank you. Thank you very much, sir, for sparing your precious time and sharing your knowledge and experience with us. Your session was very interesting and informative. You have given so much examples of various 3D printing materials and their applications, and the challenges which we have to face for using these materials also. So I'm sure that all the participants would have been benefited by this session. Also, I would like to thanks all the participants for joining and attending the whole session with lot of patience. Thank you all again. Thank you, sir.
Thank you, Dr. R.S. Gajgadsi, for inviting me and thank you for your organization, and thank you ATAL program for giving this opportunity. And dear participants, anyway, my contact is there, contact details to with Gajagad. Any queries or any related to materials you needed, you can contact me anytime. And if you permit me, I'll show you some of the things, because we are conducting one conferences at NIT Raipur. So you can send your papers, or you can register for our conference also. So that will be on advances in mechanical engineering and industrial engineering management. That will be held in the month of